Good morning, students. Today we are going to learn in the third unit remaining topics. There are types of files generated on cross compilation. Types of files generated on cross compilation. What is meant by compilation? Compilation, which is used to convert the programming language into the machine language, that is known as compilation. Once again, now defining the compilation means which is used to converting the programming code into the assembly language into the machine code, that is known as compilation. Here the types of files are generated in cross compilation are different types. There these files which are used in during the compilation process and cross assembling process. Compilation process and cross assembling process. The first one is list file, that is which can be represented as .lst. List file which can be represented in language format is .lst. .lst which is represents the list file. This list file which is used to generate the compilation process while the compiling the programming. That means compiling means converting into the machine assembly language into the machine language. So in that process, this list file which is used in the cross compilation process, and this list file which also contains cross compiler details and contains the information about the cross compilation. And this list file which can be generated in different sections. They are page header and command line. This list file which can be used in the different formats. They are page header and command line. Page header means if you are representing the any program, so that program which can be represented by the any page headers. So we have to must we have to represent the page header. Without any page headers we can't find the specific files in the list file. So that's why we are representing the page header. And command line. Command line means command lines which is used to give the commands. If you give any commands, that can be that program will be processed. If you don't give any commands, so that program will not run. That's why we are using the command line and page headers. Both these page header and command lines which are used in the list files to generate the cross compilation process, and it has to generate the different programming files, and it gives the specific information, that is known as the list file. And the next one is types of files generated on cross compilation. Types of files generated on cross compilation. Here we used different types. They are preprocessor output file and object file. List file is the one of the generated file, and another file is the preprocessor output file and object file. So what is meant by preprocessor output file? Means output means it will be get the if you are doing any program, that results will be find in the output only. So for that we are using the preprocess which are used in the during the compilation process to generate the output files. If you are sending any files, that must be checked by using the preprocessor if it output is correct or not. And the preprocessor output file is used for verifying the operation of macros and conditional preprocessor directives. That means if you are verifying any output files, so we first of all we have to check the operation of that macros, and what is the condition for that output. And what is the conditional preprocessor directives? That means what are the directives which are used in the during the cross compilation, and what are the directives which can be generated in the output file. And these are which are verified by using only preprocessor output. The preprocessor output which can also used for file extension during the cross compilation dependent. And the cross compile dependent is the which can also used for the file extension. Mm, that means preprocessor output file, these files which are used in the during the compilation files, and these output file preprocessor file which are used for the verifying the process and producing the conditional preprocessor directives. So that is the, and this file which are also used for the file extension. File extension is also available in the preprocessor output file. And the next one is object file. Object file means in the object file we can write in the machine assembly language is .obj file. .obj file means object file. This object file which can be contains different symbols, instructions and formats, and different recording files, symbolic formats. So this object file which can also used in the format of OMF51 or OMF52 are the two object file formats supported by C51 cross compiler. That means each source module translates the various embedded C or assembly instructions. This object file means which can be used to translate the embedded C and assembly language instructions into the specific module, which can be converted into or translates the embedded C or assembly language instructions into the different modules. That means particular directive format that can be represented in the object file. So if you are not giving the object file format, the embedded C cannot understand. Suppose for example, if you represent the this object file in the C language or JavaScript, it can't understand the embedded C. So only it understands the assembly languages embedded C into the specific module directives. That's why this object file is used. That object files which can support the different file formats, they are OMF51 or OMF52, and also used the CF51 while the cross compilers. CF51 used for the cross compilers, and OMF51 and OMF52 are the two object file formats. And this object file which can deals with the symbolic information, object code and debugging. This object file deals with data records for symbolic information, object code and debugging. Object file is the most important file in the embedded C that can be translates the embedded C assembly instructions into the directive modules which can be presented in the object file. And this object file which can gives the information about the symbolic information and object code and debugging. And it has the different file formats. They are OMF51 and OMF52, which supports the C51 cross compiler process. This is about the object file which can be represented in the .obj file. .obj file. The next one is the .obj file in detail, which can gives the different object files. They are reversed memory for global variables, reverse memory for global variables, public symbol names, external symbol, that means variable or function references, library files, debugging information to help synchronizing source line with object file. So different files which are contains in the .obj file. And the next one is map file. The map file which can be represented in the dot map. Dot map means the dot map which is used to link the different object files. And it is the responsibility of map file is locating the object absolute address to each module in the code memory. The purpose of map file which is used to link all the object files and has the responsibility of locating the absolute address to each module in the code memory. And the map file which contains information, link or locate process, and it is composed of number of sections. So the map file contains the information and link or locate process, and it is composed of number of sections, and it is used to link the object files in locating absolute address to each module in the code memory. So that is known as dot map. Which is the responsible for representing the different absolute address to each module in the code memory and locating the locate process and compose the number of sections. The next one is hex file. Hex file means the format of hex files which contains the process and controllers. It is the family of processor and controllers. Hex file is the family of processor controllers, and there are two types of hex file formats which are commonly used in embedded applications. They are Intel hex. There are different various hex file formats. They are Intel hex. Intel hex file is an ASCII text file in which hex data is represented in ASCII format in lines. That means Intel hex file is an ASCII text file. Which the data is represented in ASCII format in lines. And this hex file which corresponds to a hex record. This hex file which corresponds to a hex record and transferring the program and data to a ROM or EEPROM which is used as code memory storage. Intel hex file is used for transferring the program and data to a ROM or EEPROM which is used as code memory storage, which can be used as code memory storage. Hex files which are the family of process and controllers, and these are two types of hex file formats. They are Intel hex file which can be used in the ASCII format lines that contains the ASCII numbers and ASCII text file. And these Intel hex file corresponds to a hex record, and Intel hex file is used for transferring the program and data to a ROM or EEPROM which is used as code memory storage, which can be used as code memory storage. Which can be used as code memory storage. The next file is deassembler or decompiler. Deassembler is a tool for obtaining higher level codes from machine codes. Decompiler is a tool for obtaining the higher level codes from machine codes. That means assembler means which is converting the assembly language into the machine code. So this disassembler is used for higher level language from machine codes. So from the machine code to higher level language. This is the opposition of the assembler. Deassembler is the opposition of the assembler, which can be used to convert the higher level codes from the machine codes. And the process of converting machine codes into assembly codes is called as deassembling. The process of converting machine codes into assembly codes is called as deassembling. And deassembling is the utility program for translating machine code into corresponding high level language instructions. Decompile is the utility program for translating machine codes into corresponding high level language instructions. And deassemblers or decompilers help the reverse engineering process by translating the embedded firmware into assembly or higher level language instructions. Higher level language instructions. Deassemblers or decompilers help to reverse engineering process by translating the embedded firmware into assembly or high level language instructions. Deassemblers or decompilers are powerful tools for analyzing the presence of malicious codes in an executable image. See once again, deassemblers or decompilers, which is the one of the most powerful tool for the analyzing the presence of various information in an executable image. Various information in an executable image. This is the deassembler or decompiler purpose. Deassembler, decompiler are the for converting the machine codes into the assembly language, and it is the utility for translating the machine codes into corresponding high language instructions, and it is one of the most popular tool for analyzing the presence of various information in executable image, and it can be used in the translating the embedded firmware into assembly language and high level language instructions. This is the deassembler and decompiler. And the next one is the advantages of embedded system development environment. Our unit name is embedded system development environment. What are the uses and what are the advantages including in this unit is the overall cost of the system is reduced. The overall cost of the system is reduced by using these embedded C languages, and development time is reduced because of the use of software on host system. The embedded development time is reduced because of the software which can be used in the host system. So that's why the development time is reduced. It can we can develop the system in less time only. And the embedded systems are more complex in development environment. Embedded systems are more complex in embedded environment. Embedded environment, it is the most complex in embedded systems. So these are all the topics of the third unit. So this is the last topic for the embedded system development environment. Embedded system development environment. We have the different types of concepts there. First one is integrated development environment, IDE. IDE is the one of the software tool which are used for the compilers, linkers and debuggers and softwares and EEPROMs and different parts which can be used in the embedded systems. And the next one is the Keel version, IDE for 8051. So in the embedded system we used the embedded software is Keel version. So Keel version which can be used in the Microvision 3 part that can be used in the 8051. It uses the different various many options there: file, edit, debug, project, showing files, register view, books, functions tab and output window. These are all the Keel version tools. The next one is select man Keel version IDE for 8051s. Debugging with Keel version 3. Debugging. So debugging is the one of the most process of monitoring the program flow, various registers and memory contents while the firmware is executed. So in this debugging, which can be used in two methods. They are using breakpoints and simulator. Second method is hardware level debugging. Simulator based debugging. Simulator based debugging. This is the simulator based debugging and simulating peripherals and interrupts. And target level firmware debugging. Writing ISR in embedded C. Types of files generated on cross compilation. There are different types of files which can be used in the compilation of the processes. There are different files which can be used in the embedded system development environment.